Okay, I hope you people are doing well. Already exercise 1.1 completed. Today to start 1.2, some sort of general discussion will take place first. Up to now, you got the definition for natural numbers, whole numbers, integers, even rational numbers also. Today I'll define irrational numbers. In shortcut, those are not rational. You can call them by irrational. But definition, those numbers that cannot be expressed in the form of a by b, where a and b both are integers and b not equals to 0 are called irrational numbers. Another definition, non-terminating, non-repeating decimals are called irrational numbers. Non-terminating, non-repeating decimals are called irrational numbers. Now to explain this, I'll give you the idea about decimals. Decimals are two categories. One is terminating decimal, one is non-terminating decimal. Terminating decimal means where division will be over. After decimal, you may get single digit, 2 digit, 3 digit, 4 digit, but division gets over. Like this kind of decimals, 0.2, 0.25, 0.2475, these are all your terminating decimal. But some sort of divisions will take place. When you will divide, your result will continue again and again, endlessly. These kind of decimals are called non-terminating decimal. Like 0.3333 goes on, dot dot dot, that is going on, continuation. 0.252525 so and so. 0.3759 dot dot dot. 0.2437 so and so. Here some numbers are repeated, some are non-repeated, but all are going on. Dot 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 is there at the end. That is your non-terminating decimal. One example, if you will divide 1 by 2, then whatever decimal you will get, that is your terminating decimal because your division gets over. But when you will divide 1 by 3.0, 3 3s are 9, again 1, again 0, 3 3s are 9, it will continue forever. So in this kind of cases, you will get non-terminating decimal. Here you will get terminating decimal. These are the examples. Now non-terminating decimals we can divide into two groups: non-terminating repeating decimals, non-terminating non-repeating decimals. In place of repeating, we can use another word, recurring decimals also. Say first two examples from that, 0.3333 goes on, that is non-terminating repeating decimal because numbers are repeated. Here 3 is the repeated number, so this equals to, we can write 0.3 bar. In second one, 0.252525 dot dot dot, here 25 is the repeated number, so you can write 0.25 bar. Now non-terminating non-repeating decimals, that is third and fourth example, 0.3759 so and so, 0.2437 so and so. This kind of decimals where non-terminating, that is at the back dot 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 will be available and numbers are not repeated, you can call by irrational numbers. So to understand terminating and non-terminating, terminating means at the back dot dot will not be there, whereas non-terminating means dot will be there. That shows it will continue, your division will continue. Among the non-terminating, one group non-terminating repeating group, another non-terminating non-repeating group. These non-terminating non-repeating groups are known as irrational numbers. First time you are learning irrational numbers in class 9. Now regarding irrational numbers, some examples. Any kinds of root where root is not going, that is under root non-perfect square numbers, non-perfect cube numbers are available. We cannot calculate the root. Then these are all will give you non-terminating non-repeating decimals. So examples of irrational numbers, you can take root 2, root 3, root 5, cube root of 2, fourth root of 2, fifth root of 2, even pi, even this kind of decimals. These are all your non-terminating non-repeating decimals, and these are all about your irrational numbers. So shortcut you can remember, if root is available, irrational numbers. If root is going away, that is rational number. Root is left over means irrational. Root is gone means rational numbers. Now remember that TD, that is terminating decimals, you can change into rational numbers. RN means rational numbers. Non-terminating repeating decimal also you can make rational numbers. Non-terminating non-repeating decimals we can call as a irrational numbers. That means whenever you will have terminating decimal and non-terminating repeating decimal, you can make it rational number also. Whereas non-terminating, non-repeating decimals, purely it is called by irrational numbers. Again, remember that rational plus irrational, overall it will be irrational number. Like 2 is the rational number, root 3 is the irrational number. Both together you can call irrational. So irrational is more powerful, say. Rational minus irrational is irrational. 3 is rational number, root 7 irrational number. Root is there means irrational. Without root, rational. So rational minus irrational, irrational. Rational into irrational, also irrational. Example. Rational divide irrational, also irrational number. So real numbers, rational and irrational numbers are together known as real numbers. So under real numbers, rational also will come, irrational also will come. And remember that real numbers can be denoted by capital R. So for today only this explanation part. So please prepare these definitions and all very well. In the next class I'll start exercise 1.2. Bye for today.